Let's go ahead and go over the warm-up. So if we have the point A is at -3, 6, and we're translating 3 units down and 2 units right, where will A prime wind up being located at? What's the coordinates for A prime? Ethaniel? -1 and +3. Very good. -1 because if our x value is starting at -3 and then we are translating the x coordinate 2 units to the right. Remember, right and left affects the x. So you're taking your x coordinate and adding 2 to it. Going to the right means it's a +2 or a +2. Going to the left would be subtraction. So we're taking -3 and adding 2. That's going to put us at -1. And then for the y unit, we are going to be at a +3 because we're moving 3 units down. Up and down is going to affect your y. So because we're moving downward, we're going to be subtracting 3. I'll rewrite that because it looks bad. Y -3. So 6 minus 3 is going to put us at a +3 still. So that's our new coordinates for A prime. All right, for F, if F is at x -4, y +2, and we translate 5 units to the left and 4 units down, where's the new position of F going to be at? Alicia. Very good. We're going to be at x -9, and then we're going to be at y minus what? Not 4. 2. Y -2. Y -2. Okay, so translating that 5 units to the left means we're taking the x value and we're subtracting 5. Well, our x value happens to be x -4. So then we're just subtracting 5. We're really focusing on just doing this portion here. It's like a -4 minus 5, which gives us that -9. And then the same thing here, we're moving 4 units down. So it's like we're taking our y and subtracting 4. But really, we're just doing 2 minus the 4. We can't really focus on that y. 2 minus 4 is going to give you to a -2. So that's where it becomes a -2. Any questions about the warm-up? All right, so let's get into reflections and rotations then. Translations is really basic, very simple. Even reflections is pretty simple. It's rotations that has a lot of rules that need memorization or flashcards for practice. And you're going to want to make sure you do that. Otherwise, you will mess up royally when it comes to rotations. But let's start with something simple, the reflection. So for our reflection, a reflection is just a mirror image. You guys see it all the time when you wake up in the morning. You look in the mirror and there's your reflection. So it's just a mirror image for of the original shape or your original figure. And just like we called a translation, we had a different term for it. Who remembers what term it was? Translations, we also called them what? Starts with an S. What are you doing to the figure? Sliding. Sliding a translated figure. With a reflection, what do you think the slang term is for that? You're looking at the image and it's kind of backwards, right? So what is it doing? Flipping. So we call it a flipped image or a flip. So that's a slang term. Slide is your translation. Flip is going to be your reflection. And in order to do a reflection, you do have to have a line of reflection. You are going to need a line of reflection. Your line of reflection is, as it says, it's just the line that the image reflects across. So now a key thing to remember when you're reflecting, if we typically focus on reflecting across like an x-axis or reflecting across the y-axis, if you're going to reflect across the x-axis, so when a reflection across the x-axis occurs, the y coordinate changes to its opposite, which is essentially the, I know that this looks like it says negative y, but that means opposite of y. That becomes an opposite of the y. So if y was positive, it now becomes negative. If y was negative, it now would become positive. So we no longer read these as negative signs when we're talking about the reflection that's occurring or even a rotation that occurs. We call it opposite of. And then the same thing goes in hand for when you're reflecting across the y-axis. So if there's a reflection across the y-axis, then the x-coordinate is what's going to be affected. The x-coordinate changes to its opposite. So instead of x, it becomes opposite of x. So I'll leave it up for just about 30 seconds, and then I'm going to flip to page 59. Now remember, if you didn't get all of the notes, you can always go onto eClass tonight and then download them again to see the video. Or if you need to rewatch it, it's perfectly fine to do that as well. Let me go ahead and flip to the next page, page 59. And we're just going to do a couple of quick little practice problems. So let's say that we have point A is at 1, 4. Point B is at 2, 3. And then point C is at negative 1, 1. So these are the coordinates of our point. And I want to go ahead and reflect this figure across the y-axis. So if I'm doing a reflection across the y-axis, then what happens? So there's a change, yes, I understand that. There's a change. What change, though, Diego? The x becomes the opposite. So you have to identify, okay, what's the reflection? Where's the reflection occurring? Again, it's not always going to be across one of the axes. Okay, it might be across, yes, it's what it's called. If you have a plural axis, it's called axes. It might be that you're reflecting across a line, like maybe when y is equal to negative 2. If y is equal to negative 2, it's a horizontal line, just like your x-axis is, at the point where y is always negative 2. Okay, at 0, negative 2, at 1, negative 2, at 3, negative 2, at 14, negative 2, at 28, negative 2, at negative 60,000, negative 2. Okay, those are always going to be a horizontal line at where y is negative 2. If it was x is equal to 7, then it's a vertical line at the position where x will always be 7. So you have those different lines that you can reflect across as well, but we're focusing on the rules that happen about your axes and your origin. Okay, so in this case, because we're reflecting across an axis, a y-axis, x becomes the opposite. X becomes the opposite of x. So when we start off at A equaling 1, 4, and B equaling 2, 3, and C equaling negative 1, 1, the only thing that's going to get affected is the x coordinate of each of these points. So that 1, that 2, and that -1 are the only things that are going to change. So A prime now becomes opposite of 1, which is -1. 4 stays the same. B prime now becomes -2 because it's the opposite of 2. And then the y still stays as 3. And then C prime now becomes the opposite of -1, which is a +1. And then the 1 for the y still stays the same. And that becomes your new coordinates. Sorry, that should be a B prime. That becomes the new coordinates for your primed figure, your transformed figure. Ethan, did you have a question? Yes, you still have to write it as a prime because it's a transformation. Prime is not only the translations, it's for all transformations, which is translations, reflections, rotations, and dilations. Okay? So if we've got K is at 2, 3, L is at 5, 1, M is at 4, -2, and N is at 1, -1. And we're going to go ahead and this time we're going to reflect across the x-axis. I want you guys to go ahead and do this one on your own. Bless you. Yeah. Because on the y-axis, so here's my axis, right? If my shape is here at positive x values, and then I reflect it across the y, my x now becomes negative. Think of the coordinate. And here it helps if you see. So here we know that this is positive, right? 1, 2, 3. 1, 2. So if our point is here at negative, or is at +1, +2, and I'm going to reflect it across this axis, that means it's going to flip across here. So now my x with the 1, it now becomes a -1. So y-axis affects the x, x-axis affects the y. Okay? All right. Let's go ahead and identify what the values are going to become. So who can tell me what is K prime now going to be? Skylar? 2, -3. What is L prime going to be? Chelsea? 5, -1. M prime is going to be what? Austin? 4, 2. And then N prime is now going to be what? Alicia? 1, 1. Okay, so again, if we're reflecting across the x-axis, y becomes the opposite. So y becomes opposite of y. Okay, so each of these y values is what's going to wind up being affected here. So again, translations and reflections are super, super easy. Rotations is where things get a bit tricky. And then having to remember all the rules together is when people get some of the stuff mixed up. So let's talk about a rotation real quickly. So for a rotation is a figure that is rotated, obviously. Now, again, slang term. The slang term for rotation is a what? If you flip a reflection and you slide a translation, what do you think a rotation is going to be? A turn. Good. So it's a figure that is rotated or turned. There's your slang. About a fixed point. Now, this year, our fixed point is always going to be focusing on the origin. We're always going to focus on the origin. That's the rules that I'm going to give to you, is just those fixed points about the origin. And that fixed point is called your center of rotation. Now, directions of rotations. It's not called rotating it left or rotating right or rotate up or down. It's clockwise and counterclockwise. So if you forget what those directions look like, if you're going to rotate clockwise, and for all intensive purposes, I'm going to call clockwise CW for now on. So if I'm rotating it clockwise, it looks like the following. When we rotate counterclockwise, and again, since that's a handful to have to write, where for now I'm going to write it as CCW in the notes. If you see me say CCW, that's counterclockwise. CW is just clockwise. Counterclockwise goes in the absolute opposite direction. So one of those is clockwise, one of them is the counterclockwise. You need to make sure you understand what those directions mean. Get about 10 seconds to finish writing it down, then we have to go on to the next page because we got to get through these. You only have 8 more minutes. No homework tonight. Not tonight. All right. You always do well. Use proper English. You always do well. All right. So page 60. Page 60. So the following, these are the rules if you are going to do a rotation about the origin. These are only true if you're rotating about the origin as your fixed point. If you have a different fixed point or center of rotation, then these rules would not apply. This is only for the origin. So if we talk about clockwise 90 degrees, clockwise 90 degrees is the same thing as saying counterclockwise 270 degrees. Clockwise 90, counterclockwise is 270. They are the same exact rotation. So if we start at the point x, y, so I give you a coordinate of x, y, and then I tell you, hey, you're going to rotate 90 degrees or counterclockwise 270 degrees, then this is going to become y and then opposite of x. Y and then opposite of x. Remember this right here, that doesn't say negative x, that says opposite of x. So you're switching the location of your x and your y. You're going to switch their location. Instead of an xy, it becomes yx. And then instead of the value being x, it becomes opposite of x. So for example, if you've got the point -2, 6, I'm now going to change it into a +6 because the y is now going to be written first. And then instead of a -2, it's going to become a +2 because I'm taking the opposite of whatever the x was. So this is what it becomes. That's the rules if you're rotating about the origin, clockwise 90 degrees or counterclockwise 270. If you're rotating clockwise 180 or counterclockwise 180, So it doesn't matter if you say clockwise or counterclockwise with 180. 180 is 180. If you rotate 180 degrees, it's clockwise and it's counterclockwise. It's the same thing. So if you start with the point xy, xy then becomes the opposite of x and the opposite of y. So both of your coordinates stay in their same location. They just become their opposites. So again, if we had that point, -2, 6, it now becomes the opposites, +2, -6. Okay, and then if we've got clockwise 270 degrees, that's the same thing as counterclockwise 90 degrees. So starting with those points x, y, the rule indicates that if you start at x, y, it then becomes opposite of y and then x. Notice that these two are very, very similar, aren't they? They are the ones that people get mixed up on the most. So be very careful about that. So again, if we had that point -2, 6, this point now becomes the opposite of your y. What's the opposite of our y? -6. And then our x now becomes our new location for y, so -2. So it's -6, -2. Now I know that this seems like a lot. Let me just show one example, and that's why you're not having homework tonight. We're going to just do an example here, and then we'll do a little bit more examples tomorrow with both reflections and rotations. And then you're going to have, or not tomorrow, you guys won't see me tomorrow, but you'll see me Thursday. Then we'll have a station set up where you guys are going to rotate amongst the different transformations. And then we'll have a quiz. Okay? Yep, you're going to have a little quiz. It's a small quiz. All right, so if I say that we're going to rotate clockwise about the origin, I want to know what's the new location for point A, whether I'm rotating 90 degrees, 180 degrees, or 270. So we're going to do it for all of them. Okay, so let's start with the clockwise rotation of 90 degrees. The rule for clockwise rotation of 90 degrees was that it becomes y opposite of x. That's the rule. Y opposite of x. So let's take a look here. What is my y? In this point, which value is the y? 1. What is the opposite of the x? 3. So that's what it now becomes. So this is A prime. A prime is now 1, 3. If we do a clockwise rotation of 180 degrees, the rule, remember the rule was opposite of x, opposite of y, opposite of x, opposite of y. So A prime, go back to the original, what's the opposite of the x? 3. The opposite of the x is 3. What's the opposite of that y? -1. Very good. So A prime, 180 degrees, is 3, -1. And then clockwise 270. The rule for clockwise of 270, if we look back up here, it's opposite of y, x. Opposite of the y, x. So let's take a look at the y. The y was a 1. So what's the opposite of y? -1. And then what was my x? -3. So -1, -3. You're going to need to have those rules beside you when you're working these problems out. And then you need to remember them. You need to memorize them, embed them in your head, do flashcards. Now do you understand why I say we should do a Gim kit on it? It'll be a good flashcard game. All right, pack up.